This is just reporting on some recent case study farm modelling that we did, looking at mitigation and offsetting strategies to achieve the zero carbon targets. I just acknowledge my fellow researcher Tanira Kingi from Sion. Also note, I won't be writing a paper for this conference. There's a report that already exists, which you can see on the screen, which is on the, well, it's on the Ag First website. It should be on the Ag Matters website fairly soon. So basically, we are looking at 4 case study farms, 2 dairy, 2 sheep and beef, spread around the North Island, as you can see, as to what we might have to do to achieve the zero carbon targets, which again you can see there. Just to note, the nitrous oxide target for 2030 actually doesn't exist at the moment. That's to be decided by the Climate Change Commission over the next year or two. We've assumed a 33% reduction, which is, you know, a third per decade, if you like, getting through to 2050. Just to note, that's exactly what most of the government agencies are assuming at the moment. In terms of the farms, those are the 2 dairy farms, just to give you a bit of a background there. Sort of moderate size. If you look at production, a bit below average. The sheep and beef farms, the first one there, Pukekohe, sort of traditional hill country farm, running breeding ewes and breeding cows. The second one, Te Pāaka, is more an intensive, finishing steers and running a lot of dairy heifers. In terms of the process, if you like, normally we'd meet with the farm, with the governance and management, talk through greenhouse gas issues, discuss what sort of farm system changes they may be interested in. Just to note, at the start of the project, every case study farm we've worked with, the knowledge of greenhouse gas issues has been basically zero. However, we then set the farm up in Farmax and Overseer, and we'd use a forecaster for the forestry economics, although I used some forestry consultants to help work through that, and then we pulled it all together in a Excel spreadsheet. Various scenarios modelled, which I'll show you in a minute, and then we met with the farm governance to discuss through the results and get their thoughts on what they may do into the future. Just to reiterate for a moment in terms of what drives on-farm greenhouse gas emissions. Now, the first one, by a country mile, is the amount of dry matter eaten. There's a direct correlation with methane, 21.6 grams of methane per kilogram of dry matter eaten, and a strong correlation with nitrous oxide. Protein level in the diet is also a driver of your nitrous oxide emissions, and the amount of nitrogen fertilizer applied, basically because it produces more dry matter, and you also get some direct nitrous oxide emissions. So those are the 3 key things, if you like, which farmers need to think through in terms of looking to reduce their greenhouse gas emissions. And we're talking biological emissions here, methane, nitrous oxide. So those are the scenarios that we modelled. Those are the 2 dairy farms there. There's reasonable complementarity between the 2. Looking at reducing stock numbers, if you like. That's sort of a proxy for reducing the amount of dry matter eaten. Looking at taking out the nitrogen fertilizer and supplementary feed, all that sort of stuff. Planting a few pine trees here and there to get an offset. For already, we also planted a big chunk of the farm in kiwi fruit. So that's them. In terms of the sheep and beef farms, again, a similar thing, reducing stocking rate, looking at changes in per animal performance, changing stock type, if you like, and also planting a few trees. So just moving on, this is one of the dairy farms. I'll just show you one dairy farm, one sheep and beef. The slide's a bit busy, but hopefully you'll get the point. So what we've got there is the total property emissions in terms of CO2 equivalents, tonnes per hectare. We split that in terms of methane and nitrous oxide, and then we also did it again when we're looking at the forestry offset. And then the last column you're looking at the change in EBITDA depending on the scenario. So just to pick a few ones there, the first one where we dropped out our cow numbers by 10% and didn't improve per cow productivity at all, simply chopped the stocking rate. Almost a linear reduction in greenhouse gas, as you could expect, because you're eating less dry matter. But if you look at the last column there, you could say we had a slight impact on the farm's finances. When we dropped stocking rate and improved per cow production, basically, you got a trade-off in terms of dry matter eaten. You reduce cow numbers, you reduce dry matter eaten, you increase their productivity, you increase dry matter eaten. But if you go across, so we've dropped our greenhouse gas and we've actually improved our farm profitability reasonably well. Going down, looking at the forestry side of things just for a minute. So we planted 10% of the farm in pine trees. It's certainly a big impact on greenhouse gas emissions, but naturally we also dropped our farm profitability. Just to also note, in terms of the second and third to last columns there, the change in methane and nitrous oxide, including forestry, the zero carbon targets for 2030, you want methane -10, nitrous oxide -33. 2050, you want methane around -36, which is the midpoint, and nitrous oxide -100. So if you look at the planting 10% of the farm in pines, basically we achieved the 2030 target reasonably well. And in the very last one, the 24 hectares of pines, reducing stocking rate a bit, differentially offsetting the carbon credits from forestry, we actually achieved the zero carbon, or sorry, the 2050 target. The main thing to note with pines is they only give you 17 years of under the averaging scheme, give you 17 years of credit, so you have to plant a new set of trees every 17 years. Anyhow, moving on, I will skip that one, that's just another dairy farm. This is the one of the sheep and beef farms, so this is our traditional hill country farm. Again, the first scenario is the farmer was very interested in forestry, so we looked at planting various areas, as you can see, in trees and pine trees. Certainly had a major impact, if you like. If we planted 140 hectares, in essence, the farm became carbon neutral. Although we, if you look at the EBITDA column, it certainly had an impact there. We planted additional areas. Obviously, we're into a carbon surplus. If you look at the EBITDA column there, the first figure is not selling surplus carbon. The second figure is selling surplus carbon at $25. And given that carbon's down $35, obviously those figures improve markedly. Again, the rider to the clause, if you like, is that's got a 17-year lifespan, and then we run out of carbon. Again, similar to the dairy farms, you drop your stocking rate without improving performance. Yes, you get a drop in greenhouse gas, but you have a big impact on farm profitability. If you drop stocking rate but improve the per animal performance, you can offset that profitability impact reasonably well. Several different scenarios there.
About 5 minutes, Phil.
Yep. And again, just looking at the bottom scenario there, by doing that, again, basically we achieved our 2050 target. We actually improved the profitability, but again, our pine trees, which are absolutely crucial to achieving that, only give us a 17-year lifespan. Skip to per acre. So in terms of going back to the drivers of greenhouse gas emission, key one is dry matter eat-in. So if you want to reduce that, in essence, the proxy really is you need to look at reducing the stocking rate. You need to also look at increasing your per animal productivity in order to maintain your farm profitability. Without it, the farm suffers badly. There's a direct trade-off in terms of greenhouse gas emissions between reducing your stocking rate and increasing your per animal productivity. You reduce your stocking rate, you drive greenhouse gas down. You increase your per animal productivity, you drive your greenhouse gas up. In terms of reducing stocking rates and improving profitability, there's 101 little issues that spring up around your farm system and management. We would argue that's a medium to long-term process, 5-10 years plus. In terms of adjusting the farming system, we could get close to achieving the 10% methane reduction by altering the farm system, but we just couldn't get anywhere near enough for nitrous oxide. To achieve our 2050 targets, the only way we could achieve that was using forestry as an offset. I've already talked about the key issue with forestry, particularly pine trees, is that they're relatively short term. Most sheep and beef farms would have sufficient area to plant, at least to cover the first 17-year period. Most dairy farms wouldn't, so there's a big issue in terms of dairying. Certainly natives are an option. They're much longer term. Unfortunately, they sequester less than a third of pine, so you have to plant 3 times the area. And under the Zero Carbon Act, theoretically you're not allowed to offset methane with trees, but you can. You just use money. So you grow the trees, sell the carbon, use the money to pay the methane tax. So there's a transactional cost coming into that, but it achieves the same end. And the last one there is that, talking to the farmers, the Zero Carbon Act targets are actually a national or sector target. They're not necessarily an individual farm target. So whatever happens at a sector level, for example, if we get hundreds of thousands of hectares of hill country planted in trees, then that reduces the pressure on individual farms to reduce. And that's the end.